Hello, class of receiving students and teachers.
Hello, Mrs. Vargas.
You may be seated. Now, in the previous lesson, we had a look at pulleys. That was our first lesson on pulleys. Now, I'd like someone to tell me what a pulley is. What is a pulley? Let's have Gima. Receiving students, you can tell your teacher what a pulley is.
Wheel that carries a flexible rope, cord, cable, chain, or a belt on the rim.
Very good. Now, I'd like us to have a look at those two pictures that I have. We have an example of a single pulley. And we also have another example there. Now, this picture here is quite different from what we have used in the previous lesson. If I can have Sinavai to tell us what type of pulley do you think this is? Very good, thank you. A double pulley. Now that leads us to our topic, the second lesson on pulleys. And in this lesson, we will be using a double pulley. Now, as you have been told earlier in the previous lesson, there are different types of pulleys. And we used one already, single pulley. And this time, we will be using a double pulley. Now, teachers and the students, the activity that we will be doing will be exactly the steps that we are going to follow will be just like the steps that we have followed in the first lesson on pulleys, on using single pulleys. Now, before we go to the activity, I'd like us to have a look at what I have here. A single pulley, when we look at a single pulley, there are two strings. We have the first one that is attached to the load, and that is string A. We have the second one that is attached to the force meter, which is the spring balance. So in a single pulley, we have rope or string A and B, one for lifting the load and one for measuring. As our lesson is going to be on double pulleys, I'd like us to have a look at the sample of our double pulley that I have. Now, there are three strings or ropes. We have this. That's string A or rope A. We have the middle one that is attached from the top pulley, and it goes down and goes around the second pulley. This is our second rope. That's B. And we have the other that is attached to the force meter or the spring balance. That is string C. A is where the load is. B, attached from the top pulley, goes round and goes up to A. C comes down from the top pulley to the force meter, the spring balance. Class and receiving students, when you are doing your activities, I'd like you to take note of what happens to string A, B, and C when you are doing the experiment. Now you have been to set up this double pulley. You tied one end of the string to the top pulley, and you bring it down. It goes under the second pulley, goes up and round the top pulley, which is the fixed pulley, and it comes down. Then you tie it to the force meter or the spring balance. Now, students in the receiving school with your teachers, you have just seen how a double pulley can be set up. So our first part of the activity is to set up the apparatus as shown. And the strategy receiving teachers that we will be using is shared learning. Once again, we will have the students to work in their groups, 2 groups working on the same load. And after that, they will be brought together to share whatever they have come up with, the results, and to confirm that they have the same answers. Okay, so if I can have the class to come up and receive your or get your apparatus that you need for your activity. Okay, if you want, you can use that or that. Now, class and the receiving students, I'd like us to go quickly through the steps. We've already done that in the previous lesson, but just to remind us, in case some of us have forgotten the steps that we have to go through. So let's have a look at our second step. That is to put a mark on the retort stand 10 centimeters above the base of the stand. Third, you are to take the mark of the load and the effort distance at start. That's when you are beginning the activity. Now fourth, you slowly pull down the spring balance or the force meter to lift the 100 gram or 500 gram load until the bottom of the load is level with the 10 centimeter mark on the retort stand. You have been teachers, you have a ruler, so the ruler can help the students to mark the 10 centimeter mark on the retort stand. Now, after that, you are to measure, 1, the reading on the spring balance. That is the effort needed in newtons. Secondly, you are to measure the distance the spring balance moves. And that is to get your result for distance moved by the effort. 6, you are to record your readings in the table provided. And the reading that you are going to record is going to be the effort needed and 2, the distance moved by the effort. Now 7, you are to calculate the work done. That is 1, work on the load, and also 2, work by the effort. Use the formula work equals force times distance. With work, carry out. Which unit do you use for work?
Joules.
Joules, thank you. Doveri?
Newtons.
For force, unit?
Newtons.
Newtons, thank you. Messi? Distance?
Meters.
Meters, thank you. Now, you are finding your answers or your readings in centimeter. Once you find it in centimeter, you have to convert that to meters. 10 centimeters is equals to 0.1 meter. Let's have Raymond to tell us, if you get example, the reading is 25 centimeter, how can you convert that to meters?
0.25
to 5 what?
meters.
Thank you. Okay, our class and the students are in the receiving schools. You already know, as I've already stated earlier, I'd like you to start on the activities. Groups 1 and 2, you are working on the 100 gram, and groups 3 and 4 on the 500 gram mess. Receiving students and the class, you should have the copy of your worksheet that you used in the previous lesson. Have it there with you, so after you have done the experiment with the 2 pulleys, I'd like you to compare the result you got from the single pulley and the result that you will get with the double pulley. I didn't bring the water. Okay? So you are able to pull it out. Down this way. You don't pull it out, you pull it down. Okay, you say you have to do that. Bring your stand, your retort stand to the edge so you're able to, you don't pull it out this way, you have to pull it down. Okay? So you have to bring your retort stand. Okay, because this is light, somebody has to hold it. And when you get your spring balance, you bring it down, don't bring it out. Shane, you and your friends, the retort stand has to be at the edge. So when you pull the force meter, you bring it down. You don't have to bring it. Okay. Over here. Your retort stand, sorry, Carol. Your retort stand, you can bring it to the edge. So you pull your what down, because when you pull it this way, that's not down, you are pulling it out. It has to go down. Okay, bring it to the edge. You're doing the 100, not the 500. 500, I already made it clear. 3 and 4 are working on 500. You're working on 100, so you compare your results from using single pulley with double pulley. Make sure you have your results from the first lesson on using single pulley. So the results you get from the double pulley, you have to compare that, and that is where you're going to write your summary.
Give it to them so they can identify which strings ABC.
You did already, yeah. Okay, thank you. Here, put your these tags on so you know which one is A, B, and C. Someone put your tags on your string so you know which string, because you have to observe to see what happens to these different strings. You put your tags on. Go and give it to the other hand. A is where the load is.
What is the load?
Yeah. B is in the middle. While you are doing the experiment, you have to see the movement of the strings. Yeah. Okay, it's not new, so you should be already completing it. Tony. Take that.
Switch on. Mic.
He wanted me to talk. Tony wants me to talk. Tony like me a lot of talking. Okay. You should be on the 5th step now. Taking the measurement. Have you got your measurement already? Have you got your measurement for the... Why do we have only 3 boys working? What about girls? But we should have a girl and a boy working, so the others what? We cannot have only boys doing the activity. Girls must also help in there. Okay, get your fake out. You are blocking the camera.
Okay. 744.
You're on the 5th one, huh? Okay. Are you on the 5th step now?
57.
What's that? Or the professor? Uh-huh.
We have to measure the distance from here to A, B, and
Yeah, that is your marks from the start. So we are doing that, your marks from the start. Before you begin the activity. Okay, you already finished it. Have you come to that one there yet? Distance moved by the effort. So let's see. Okay. Okay, Raymond, you haven't written yours down yet. Trisha? Yeah. You're working on the 101. You're working on 100, so you try to compare your results with your results from that one fully. You have been told that, but I think you did not listen. You are on the 500 gram. You should be now recording your readings.
No, you're not supposed to put 2 Newton here. And the work done on load.
You have to do that first. After that, you go and calculate to find your work done on load and work done by effort. We already got this done.
Missy.
Careful. Have you finished? Let's see.
Work done on load and type sheet with what?
To find that one first.
Distance
You haven't done that yet, and you see the girls already got it done. You're saying you're working on it, and the girls are calculating it, so you should get it from the girls. And to find the work done, you have to use the formula work equals force times distance. Now you should be calculating to find your work done on the load, work done by effort. Once you have found your distance moved by effort, what are you going to use? Messi, what formula?
Force times distance.
Okay, so you use that one and you find your answers for that and for that. Make sure you all have the same. Let's see.
So you go to
Times it when we're gonna times first times distance.
You use this to find your work done by effort. You use this here. Okay, that's your force times the distance to find your answer for work done on load. Your force and work done distance is already there for the one on the left, right? You use that. Okay? You use that effort needed. That is your force times the distance, and you get work done by effort. Careful with those things that you don't. You already got your water. Yeah. Okay, don't worry about this because I didn't get that for the receiving schools. You only have hours under what it says. You write a summary. Compare. You compare your what from the first one, the single pulley, and the second one. What's the difference? What can you say about single pulley and double pulley? Okay. You can just concentrate on this one. Work done by effort and work done on load. Okay, and then this one here. That one for 100 only. This one and that one. What can you say?
They were the same. But as for a single pulley, it was 6. But for this one, it was 19.
Okay, so here you have effort moved by distance moved by effort. You have 6, and distance moved by effort. You have 19. Okay, since that most of us have finished, we are going to be coming together for shared learning. Group 2, you come over to group 1. Group 3, come over to group 4, come over to group 3. Group 2, when you come, just stand around. They will sit, but you stand around. Okay? 4, when you come, you stand around. Come with your results table so you can share with your friends what you got there for your results. Move quickly. Here, some of you. Come. Come around. Okay, you discuss what you got. Edward, you and your friends, tell your friends. Okay, 3 and 4, let's have Hayano. She will tell you what she got in their group, and you people tell her what you people got and see whether your results are same. If it's not same, then what's wrong? You will have to try your best to find out. Maybe you do it again, and that's it. To confirm your results, that you all have the same one. Now, this is what you are going to do. We will have Linda from group 1. Linda is going to tell group 2 what you got for your results. Okay? And we have Tassie to tell group 1 what you got for your results. Now, your results must be the
how
same.
we got the
If they are
work
not
done
same,
on load,
then
we
you will have
multiplied
to
the
try
distance
again to
moved by
make
the load
sure
plus the
your
times the
results are
force,
the
which
same.
was 5. We got 0.50 joules. Okay, our effort needed was 2 newtons, and we times it by the distance moved, which was 0.19 meters, and then we got 38 joules.
How we got our answers are quite different from you people. We got the work done on load. Work done on load. Distance moved by the load was with times how we got the work done on load. The answer was 0.50 joules. How we got it was with times the load in newtons 5.0 times distance moved by load was 0.1 meters. So we times the two of them and we got 0.50 joules. How we got work done by effort? We times the effort needed was 0.3 newtons. We times it by the distance moved by the effort was 0.44 meters. We when we converted it, we came up with the answer 1.32 joules. Multiplied it.
The load is 100 grams, which in newtons is 1.0 newtons. We times it with the distance moved by load, which is 1.1 meter, and we got a work done on load is 0.10 joules, and our effort needed is 0.2 newtons. Distance moved by effort is 0.16 meters. We times it and we got work done by effort is 0.32 joules.
Um, the distance moved by the load, the work done on the load was 0.10. The effort needed 0.1 Newton. The distance moved by the effort 0.19 meters, and the work done by the effort was 0.19 joules. How we got our answer? We multiply the distance moved by the effort and the effort needed, and we got the answer 0.9 joules.
Thank you, class. If I can have you to return to your seats quietly. Now I'd like someone from the two groups. We'll have someone from these two groups to tell us the class of your comparison of the two results from the single pulley and the double pulley. If I can have Violet.
Okay, our results with yesterday's, we found out that there is less effort needed in a double pulley than in the single pulley.
Let's have query for the 500-gram mess. Query.
We got work done on load was, we divided by 5.0 newtons, 5.0 newtons times 0.1, we got 0.50 joules. And the effort needed was 2, and then 2 newtons. Distance moved by effort was 0.19, and then we got 2 times 19 gave us 38 joules.
Now, so what do you say about the two? That's how you calculated your work done by effort and work done on the load. But what do you say, just like Violet has done about the 100-gram mess, what do you say about the 500-gram mess?
There was less force.
Okay, thank you. Thank you, Quarry. That is what the students have come up with, receiving teachers. I hope you're able to get through. If you are not, then in your own time probably. After this lesson, you carry out that experiment and get the students to compare from the first lesson on pulleys to this lesson. Now a summary. Ropes in a double pulley move up and down. That is, rope A goes up and rope C and B and C, they come down when you are using it to lift the load. Two double pulley system can also change the direction of the force just like a single pulley system. the amount of work done by the effort is greater than the work done on the load. That's what we found out from the two experiments we carried out on a single pulley and double pulley. Now, if I can have Aloysia to give us the key phrase for this lesson.
Double pulley.
Double pulley. Okay, let's see what I have. Less force, more effort. Our next lesson is still on pulleys. That's the third lesson. And teachers, we are still using the same materials. And with that, thank you, class, the receiving students and teachers for your participation.